In this video, we'll go through the steps required to make this simple 2-inch right-angle part shown in the illustration. The material will be a flat piece of 063 5052 aluminum, 2-inch wide by some length L. We'll need to cover 1. What the flat layout length L needs to be to produce 2-inch flanges. 2. What bend allowance is required for material, bend angle, and radius. The tables in the machinery's handbook will be helpful. 3. Setting up the press brake's back gauge to make the 90-degree bend. 4. Making the bend and checking the part's dimensions against the drawing. There's a link in the description to more details, bending theory, bend allowance table, and formulas. Let's get started. A fully specified drawing for this part is shown. There is a PDF version in the details link which you can print for something more readable. The drawing includes flange length, outside dimensions, material, bend radius, and the required flat layout to produce this part. The flat layout length L is simply the sum of both flange lengths, 1.875 inches each, and the bend allowance, 0.138 inches, for a total length of 3.888 inches. Since the flanges are equal, the bend center will be half the total flat layout length, or 1.944 inches. The back gauge will need to be set for 1.944 inches. The terminology used in the drawing, mold lines, setback, neutral axis, bend lines, etc., are explained in the details link. Not required to make this part, but good to know for a deeper understanding of how sheet metal bends. When metal bends, the inside surface compresses and the outside surface stretches. Looking at the cross-section of the bend, the neutral axis is the theoretical location at which the material is neither compressed or stretched. Its location is a function primarily of the material, steel, brass, or aluminum, and hardness. The location of the neutral axis is measured from the inside bend surface as a fraction of the material thickness. You'll see a number, sometimes called a K factor, less than 0.5, since the neutral axis isn't central but closer to the inside bend surface. The Westinghouse Electric and Manufacturing Company did extensive research on bending groups of materials ranging in thickness and being bent along a range of radii. Those results are published in the machinery's handbook as bend allowance tables. This removes the need to know where the neutral axis is located. The bend allowance is that amount of material required to sweep the bend and can be read directly from the table. Mathematically, it's 1/4 of the neutral axis circle's circumference. If you look at the table entry for 1/16 inch thickness and a bend radius of 1/16 inch, you'll see where the 0.138 inch number came from. No known formulas exist for calculating the K factor. If you know the K factor for your bend conditions, formulas will be found in the details link to calculate a bend allowance. It's easiest to use the tables. Okay, let's go ahead and blank out a piece of metal here. This is my aluminum pulled out of the scrap box. We're looking for 2-inch wide, so we're 7 thousandths over there. And we're about 10 thousandths over there, so this piece is not quite square, but it'll be good enough. From my drawing, my length is going to be 3.888 inches, so let's set that up. 3.888. Lock that in. Put a scribe line on the piece. Put one right there, and we can put one right there. And we'll just snip this off. See how close we get. Cut that off. Let's see what we get here. We're about 12 thousandths over, so that's not so good. So let's see if I can nip off a little bit more, just to get that a little closer to where we want to be. All right, let's see what that does for us. Okay, so we're 3.887, so that brought us into within a thousandth of an inch. So this will be our blank piece that we'll go ahead and make the right angle from. We'll go through the press brake setup pretty quickly. It's been covered in another video. Step number one is you want to make sure your upper die and your lower die are parallel. So you can do that. I got a piece of PVC, 1/4 inch PVC here. We can slide it in there, kind of use it like a feeler gauge, and slide it along and make sure that we've got equal resistance along the length of the die. So I got it set up here so the two dies are parallel, so that will give us an accurate bend. A couple things. You'll need to know the distance from the die's bend center to the back of the die. This is 0.562 inches for my tooling. I'll go ahead and register the back gauge against the die, zero the DRO, then advance minus 0.562 inches, so the back gauge is directly under the bend center. I'll zero the DRO and bring the back gauge out to 0.562 inches as shown. You'll need to open a space between the dies to allow the back gauge to come under the bend center. From there, you can continue to crank out to 1.944 inches as shown. This will be where you'll make your bend. Your setup may be different, but the concept remains the same. With the back gauge set, we can make the bend. Okay, we got our press brake all set up. We got our back gauge set here at 1.944, which is half the length of this piece. So we've got our dies set parallel. We'll just cycle a machine once, ready to make our bend. We'll put the piece in here, get it registered on the back gauge, make our bend, flip it over. We can hit it one more time. And there's our bend, so we'll check it out, see how close it comes to the drawing. Okay, here's the part that we just bent. This is actually a second piece that I made for this video. The first test piece that I made is in the text description. So let's take some measurements and see how close we got to our drawing. So we're looking pretty good there for that leg, and I'm going to say we're within a thousandths of where we need to be, and then we'll flip this around and we'll go this way and this way, and we'll measure the other leg. We'll see what we got. It's supposed to be 2 inches, so let's see what we got. So it's off by a couple thousandths, which is pretty darn good considering. So that bend allowance that's in the machinery's handbook for this material, 063 5052 aluminum, is pretty good. So, and the DRO on the back gauge and the press brake is really good too. So I'm pretty happy with how this came out, and it's certainly well within the 10 thousandths that we were hoping to get. The summary points shown will help you make accurate bends. Machinery's handbook has good bend allowances. Make sure your back gauge is set square and accurate. Cut sheet metal square and accurate for best results. Know your tooling dimensions and make sure they are accurate. Bend a test piece to check bend allowances. Visit the details linked in the description for more information. Always work safely around machinery. Again, always work safely around machinery.